I make sure our progress in math from K through 5 is aligned. I'm going to start a little different. I put out these fraction tiles, and I suggested you could put them in order, and somebody joined the table and said, oh, you're not late, I'm just playing. I really want you to consider what a great word that was. Because when we play with things, we learn a lot. And when we keep thinking of math as hard or tedious or boring, we literally are sending chemicals into our brain that makes it hard. When we enter it with that idea of we're playing, I mean, I could do an hour with you right now, just looking at this, and what could you tell me? I'm going to take 5 minutes. I'm going to take a minute. What can you tell me just looking at these strips?
How you can divide one whole?
So we can divide one whole. Absolutely. That blows some kids' mind. Yeah, we can divide a whole. What else? What else do we know?
Partitioning?
Yep, we're partitioning. Into what?
Fraction.
But specifically what? What are the yellows?
Quarters.
Aha! I picked the yellow on purpose. Are they quarters or are they fourths? They're both. Just like some kids' names are Joseph and Joey. We have to talk about that because the world uses both. In the math class, that particular one, my sneaking suspicion is more kids, I can't say English, with the British background are more likely to say a quarter. Americans will say it because of our money, but I also think when I see fractions, I think more kids are going to say a fourth. Or that's where it's going to come from. And other kids have never heard a quarter and we need to discuss it. We can talk about what do 2/4 equal? And? It equals 4/8. You can see it. I'm not going to be able to do it on my calendar. So I got 2/4 also equals 4/8. What else does it equal? 6/12. All these things that we're playing with. Oh, good, you got it back. So again, I appreciate that term play. I would really, really encourage you to keep that attitude towards math always. And sometimes in play we struggle a little bit more than others. So I want to do 2 little refresher things. Would you turn to the first page? And it's going to have a lot of vocabulary. You knew this all at one point in time. You knew most of it at one point in time. But I'd like you to just take a little refresher just to remember what we're talking about. The strategies at the bottom, not so much, but the vocabulary you did know. Set you up for what your kids entered 4th grade knowing, or at least having been exposed to last year. They do know that fractions are supposed to be equal size. They struggle if they don't look alike. So we have to do a lot of proof to them that they actually do not have to look exactly the same to be a half. Let me do a quarter because I can give an example off the top of my head. If that were perfectly drawn, those are each quarters. We have to prove that with kids. Often we have to take scissors out, cut them apart, and see that they're equal. They did that in 3rd grade. We're having to remind them. I was just in a 4th grade class this morning at the beginning of fractions, and this one was tough, but kids could reason it out. I want to talk about the drawing also. Kids reached for their rulers, and I said, no, 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 no. Really what we want are kids who can reason. I'm never going to draw that exact, whether I have a ruler or not. I might get better if I was on the computer, but I can draw it reasonably. But we do expect some sort of reason. At the beginning, I accept a lot sloppier drawings. By the end, I want them to slow down and do something that's, within reason. But that's what thinking is about. It's like, okay, I know that should have gone straight, but I can still reason that that's important. If you were really hungry, and I brought in the absolute best cookies in the world, would you prefer to have a quarter or a half? Remember, I said they were really delicious. One other thing they learned in 3rd grade. You needed to ask me another question. Were they the same size? Because if I made itty-bitty cookies and a giant cookie, a quarter of that giant cookie is a lot bigger than that half. So we talk a lot about equal sizes, and they have to come from the same whole. Because if you don't have those 2 rules down, everything that we do falls apart. They'll get to the point, I'm not going to make a child constantly say from the same whole once the unit gets going, because we can make some assumptions. Did the rest of the vocabulary make sense? We will be going through and talking about these strategies, and what we're talking about, that's less to do with fractions as it is to do with a way of notation. 4th grade is very much about the equivalence of fractions. And once we understand the equivalence of fractions, we can start adding things together with unlike denominators. Not that we always have to change the denominator, because there are several ways we can break things apart. But that's the big part of 4th grade. The only multiplication that comes in is if we change 1/2 into 6 sixths, we have 3/6, and then we will show them that is 3 times 1/6. But really, we're not multiplying fractions, we're using an equation to describe the amount. Multiplying and division of fractions is for 5th grade, and fluency of multiplication and division of fractions is really 6th grade. 5th grade, they get to it in multiplication, but not in division. Okay, first of all, we're just looking at these fractions. A tape diagram is one of our favorite models. It shows right now how many fifths. I just gave you the answer. These are fifths. And how many shaded do we have? 2. That was a bad question on my part. What fractional part is shaded? 2. Fractional part. 2/5. So we do use that naming of the parts. It is 2 pieces. I do agree with you. I asked that the first time. That the fractional part is that's 2/5. And our whole, as I mentioned about the cookies, our whole is labeled. That is an important part the whole time. Because with a different label, if this had been my 1, we would have had 2/4. So again, to make sure we're all looking at this the same way, we need that label. A number bond. I can break 1 into 4/5 and 1/5. A number bond simply shows us I have a whole, and then I can break it into parts. I could have broken it And it does not always have to be 2. I should say I have a quantity and it can be broken into parts. I could do this. I could do 1 1/2, and what would this last one have to be? Right. So a number bond just shows a quantity and how it can be broken into parts. There is no rule about how we break it into parts, but our story will tell us how we should do that. Okay, I know the real timing. Your children, this is a big, big unit in 4th grade. In fact, they've split it in 2. They're going to do half of it. They're going to have a week off, then they're going to have spring break, and then they're going to have a second half. I am going through all 8 to 10 weeks of fractions, so we're going to be going at a fast pace because I'm not trying to teach it to you, I'm trying to show you what your kids are going to learn. So please, if something's not making sense, we may roll on to the next problem. I can help you later, or you can wait till your child gets there and you two can figure it out together. But we are going to roll through this. So a lot of this I'm just going to show you. This is what we're talking about, what we're doing with the kids. Draw and shade a tape diagram of 6/7. I'm going to break this into 7 parts. Without getting too confusing, we do need to, the kids were instructed in 3rd grade to break something into 7 parts takes 6 lines. But we don't want to talk about that very much because we don't want that 6 becoming part of the fraction they're thinking about. But there is a practicality of how do you draw it. So I'm going to use 6 lines. Yes, I draw fractions a lot, so mine were pretty good on the first try, but I really didn't work too hard on that. Drawing, and then it says shade 6/7, so I'm going to do 6 of the 7 pieces. So now we have this 6/7, and I want to know 3 different ways to break this apart. I'll give you the first one. I'm going to break it into 3/7 and 3/7. And that would look like, whoops, well, no, I'm going to write that large. 3/7 plus 3/7 equals 6/7. Would you go ahead and do 2 more? Turn and share yours to see if you did the same with your partner. Okay, you know where it is though. Okay. So this is this idea that kids know how to decompose numbers. We've been using number barns since kindergarten. And being able to think of fractions as a composition of quantity, it becomes a great strategy to have later on. We always did it with whole numbers. We didn't used to show kids that they can do it with fractions and make their lives easier. So this is why we're practicing this. I switched to blue pen. I didn't realize I was writing orange. This was today's lesson in grade 4, across the way. This is the area model. This is a very particular model, and we do have to teach them how to draw it because there are some rules to it. It is not the only model we will show them, but today we wanted them to do the area model. To find the area, you multiply length times width. That means we have to do certain things of these to be able to read that. So within our area, does this tell us what to do? This says we have half. The way we teach the kid is we always divide it, I'm going to use that term wrong. Well, what I'm going to use it anyway, vertically first. And we have 1/2. This then asks us to make 3 rows. So I have 2 columns for my halves. I have 3 rows for my thirds. Does that make sense? So I've gone from a fraction of 1/2, and how many are shaded? Well, first of all, how many new pieces, how many equivalent pieces do I have?
6.
I have 6, and how many are shaded?
3.
So they got us started doing that over here. We do look at unit fractions an awful lot. Unit fraction means it has one of the pieces, so the unit means 1. So I have 1/6 3 times. So they were asking us over here, 1/2 equals 1/6 plus 1/6. I'm sorry, 1/6 plus 1/6 plus 1/6, and it means I have 3/6. So again, what does that equal to? 1/2 times, I have my 1/6, I have 3 groups of it, and that equals 3/6. This is just a way to show them multiple representations. We have it in drawing, and a couple different ways we can write it in an equation. And as we progress in our mathematics, there's going to be different times when that's what I want versus that's what I want. So we're just showing them the equivalency of all these different notations.
Are you guys going to tell, do you guys teach kids like if there are 2 fractions to be added and if they have the same denominator, you write the same denominator and just add the numerator? Do you teach them like that?
That really was 3rd grade
Okay.
with common denominators. We will start adding unlike denominators this year, and this is where we're leading up to how do you find the common denominator. So yeah. But you know, we have to keep proving that to them. I mean, a young lady today definitely added 1/5 plus 1/5 and got 2/10. But we had a picture there, so I kept going back to her. I said, I don't see that. Where do you see it in the picture? She goes, right there. And I said, I don't see 2/10. She goes, no, that's 2/5. And I went, right. And, you know, so yes, we are constantly having to refresh, maybe I shall say, for the kids. But me just telling them, you just add the numerators and you leave the denominators the same, really makes almost no difference. Luckily, the way this problem was set up, she had the picture right there, and I kept saying, well, show it to me. Where's your evidence? And when she went back to the picture, she was able to correct herself. Okay, so what fraction do we have on B? 1/4. It says make it into 2 rows. No problem. What equivalent fraction did I make? We are talking about language here. We very much call this 2/8. We want them to think of this as a number. Not 2 out of 8, which is actually a set model, that can be correct. Not 2 compared to 8, which is a ratio, which they will do in 6th and 7th grade. Right now, 2/8 is a fractional part that lies on a number line between 0 and 1. We really want to make sure they understand that. So our language is pretty particular. The TH at the end becomes problematic, especially for some kids from certain languages. We work on it. Okay, so we have 2/8. So I have 1/4 equals 2/8. So I also know that 1/4 equals this one and this one as an addition sentence. So I can write 1/8 plus 1/8, and that equals 2/8. I can kind of feel high and mighty and mature and say, I can use multiplication. I have 2 groups of 1/8. Okay? So that was understanding how we can find an equivalent fraction with a lot of support. Now I'm going to ask you, can you prove to me that 3/5 equals 6/10? So we've given them less information. So what do kids need to know here? They need to know what to do to the fifths to get to tenths. They need to know their multiplication tables. They need to know their facts. Being fluent in multiplication facts through 100 is an end of a third grade standard. We know a lot of kids don't have them yet, and now this becomes a real big problem. I mean, it was a problem when we were multiplying numbers, but they could probably take their time and figure it out. And now that we're trying to find common denominators, they really need these facts ready to go because they've got something else to work on. The last page, double check. The top of the last page gives you 6 or 8 games that your kids could be playing if they're having trouble with their multiplication facts are not fluent. Okay, so I know to get to 5 to 10, I need to cut that 5 piece, I need to make it 2 times as many pieces, not 2 times bigger, it's 2 times as many pieces. It's still the same thing. So, I have proven that now I have 1, 2, 3, 4, 5, 6 of these pieces, and their value is tenths. Okay. Compare fractions, find common units for the numerator or the denominator, and are these greater than or less than? Honestly, to do this, we're going to find the common denominators. So, if I have 3/4, I want to use different colors. A lot of the teachers just have them drawn in. I have 3/4, and I want to know whether it's bigger than or greater than or less than 2/3. Well, I have my 2 drawings, and I'll be honest with you, I don't really have an answer because I can't draw these accurately enough to know if they are, which one's bigger. I mean, I'm guessing 3/4, but they're awfully close. So I can use the fractions. I can say, okay, 4 and 3, and at 4th grade they're going to know, well, wait a minute, let me divide this into thirds. What am I going to multiply? I shouldn't say I'm using that. I'm going to multiply this into 4 parts. Can I still tell just by the orange part? I personally need to count them. But I now have 12ths here, because it's 3 by 4. And I have, how many of them? I have 9 12ths colored. In this one, I have 4 by 3, that is still 12ths. And I have 8 of them colored. I've now proven that 9 12ths is greater than 8 12ths. Yes, there are other models. To do this, I'm showing you the area model, how to do this. It would work on a number line just as well. You could tell greater than or less than from that. Does that make sense? How about doing the next one? I have 1/3. I have 4/9. Oh, that's interesting. I don't want to do it the way I was teaching you. I changed this number. Now, can we go with me? Now, this is why I shouldn't change numbers at the end. If I know I want to go from 3rd to 9th, I can do it right on this first drawing. I don't have to have a second drawing. In fact, I don't really have a way to do the second drawing that's really going to make any difference. So if I have 3rds and 9ths, I really only need to change my 1/3 to 9ths. So now I have 3/9. And is that less than or greater than 4/9? It's going to be less than. this was where I got off. I wouldn't draw it a second time because I can make the comparison from the first one. We honestly would probably start with this problem where we were only changing one fraction first. What I almost led us down the path, and this is where we want people thinking, because I could have done that one into ninths, then I would have had to do the other one into ninths and the other one into thirds, and I would have ended up with 27ths. I guarantee you it would have worked. It would have been really sloppy. It would have been very difficult in this size of a paper. So we do want kids thinking, can I make something first or easier to compare? Okay. We walk, at this point in the unit, we're going to walk away from the area model a bit and we're going to get into adding and subtracting. We then circle back to the area model later. We've kind of let it sit. We've let it, we call it percolating in the head. So we're going to walk away from this for a little bit and we're going to go to the models for addition and subtraction. And this is a tape diagram. I am not showing, I'm showing you certain models as we go. You'll end up seeing all the different models, but I'm not showing you the model, each model for each problem, because we don't have 10 weeks to do that. The kids do. Okay, this is the tape diagram. As again, I'm sorry, bar model, exactly the same thing. One is from Singapore Math, and one is now what the Common Core and most of the world uses. You will see that they definitely told us what the value of 1 is. That's very important in this drawing, because the tape diagram does show us a quantity greater than 1. As a matter of fact, it shows us 1 1/5. So on this child's thinking, they had 1 1/5. And this would have been labeled 1/5 and 1. Knew they had to take away 2/5, so they went ahead and cut up the 1, or partitioned the 1 in 2/5. Does that make sense? So now they're using the 6/5. They're taking 2 away, and that leaves us with 4/5. The next model looks pretty similar, but there is a little bit of a twist to it. This one, they decomposed 1 1/5, and they kept the 5/5 and the, 1/5 separate. So the child is only looking at the whole. They're going to take what they know away from the whole, which they can do. 5/5 minus 2/5 is 3/5. So we have that 3/5, but they have to tack back on the 1/5 that was there at the beginning. This is going to make a little bit more, well, I think it makes sense, but it's going to make a little bit more sense when we see in other type problems. Find the difference in 2 ways. So 1 1/4. I'm going to draw, well, I should have drawn my 1. I will tell you, I as a teacher would do that for my 1 1/4. Because unless I have a label there, I mean, you now know the value of that because I broke it into fourths. They're not showing it to you that way. Both of them are accurate as long as they're labeled. I just, for a beginning student, I want that picture there of everything for them to be able to figure out. It's not right or wrong one way. Okay, so I have 1, and I guess I can label this 1/4. I'm sorry, and then I started breaking this one. I partitioned it into fourths. Now I'm going to take away my 3/4. 1, 2, 3, and I get an answer of 2/4.
Are they expected to break that down to 1/2 yet?
2/4? No. Simplifying fractions is no longer the absolute must that it used to be. Because, I wish I could think of an example right off the top of my head. Let's just say a pizza. If you have 2/8 of a pizza left, you really do. It was cut into 8s. yes, you can see it as a fourth, but honestly, you've got that cut there, and it is 2/8. There's times when that becomes important. I would accept anybody who simplifies it, but we just don't require it anymore. We do teach it. There's also times up in algebra where you really don't want kids simplifying. And in fact, when you're going to solve a problem, often you're unsimplifying it. Actually, you are making it a different fraction that isn't simplified, so we don't have that ingrained of, oh, we can't do that, oh, we can't do that. But we do, that's more of a 5th grade skill, although they do know a lot of these, and kids will. And most of the kids who do it is because their parents told them to, or they've got an older sibling. It's not really a natural thing to do. And I'm going to eat my words on that a little bit. If we've been talking a lot about equivalent fractions, there are kids that are going to see it and try it. And yeah, I'm going to take that. But this is a perfectly fine answer for this problem. So how would be the other way? I'm going to draw my 1 1/4. And then what I'm going to do is I'm going to take it away from my 1 first, and then add my remaining parts back together, and I still get 2/4. So if I can sum this up in Word, the difference between these two, or the difference between this one and this one, is that one, they're just subtracting away from the whole, because that is pretty easy to do. 1 minus 3/4, kids really don't have to change it to 4/4 minus 3/4. They know it's 1/4. And that's a really good mental skill.
Sorry.
Yeah.
It's the J pattern that you just drew for the 1 1/4 right now. You know how you have done 1 as a whole number, and then you have the 1/4, and then you have the 3/4 that you've cancelled out? Wouldn't that be a little confusing, as in just as a, when I look at it visually, but as a 4th grader, instead of drawing it like that, if you do it how you have the problem on top, where it doesn't show the extra, don't you think that would be better?
Yeah. Okay, let me, I went 2 ways listening to you. Do you think it's better not having this here? Is that what you mean?
Yeah.
Okay.
Because then
Is that what's taken away versus what was crossed out to begin
Because I'm
with?
thinking of my
Yep.
son as in, did I take this away, or was this part of it?
And you know what, that may be exactly why they did it. I did use 2 different marks, but I could understand where you're saying, oh my goodness, now I have to remember the 2 different marks. Okay, I'll quit doing it that way. No, and I think that's a really good thing. I think there are a few kids that aren't going to understand what the value of this is. And worse than that, I think there's going to be kids who don't understand it and just accept that it's a 4th because I say so. And I want them thinking. I agree, I can absolutely see what you're saying there. It's like, or it's kind of like I wish I had a whiteboard, that I drew it this way, and then I was able to erase this. Because I proved that that was 1/4, and that's the part we really want to look at.
Well, but my next point is, do you require them to show?
No, I think most kids, I think they're going to be shown mostly this way. I think there will be a child or 2 that I would end up talking to, that they might need to see it this way. And in talking with you, now I could see where I think I'd rather show it to them on a whiteboard, where I could get rid of that. But I think struggling mathematicians might not understand where that value came from. They just think it's magic, and we can't. Math can be magical, but it can't be magic.
That's good in the initial phase, the way you showed, but later maybe you can.
Yeah, and I may be falling prey to what I'm telling you not to. Yeah, they could have been doing this earlier, and it's absolutely not needed by now. Where I was looking at it today, rapidly through it, thinking, how would they know that? Was that the same question you had?
It was, because
Yeah,
I'm like,
okay.
why I only have 3 to X mark, I cannot.
Yeah, okay, let it go. I'll do the next one without it. And now I'm kind of with you. I think they've probably done understanding 1 1/4 earlier enough practice in the time that they can accept it. Because at this point in their knowledge, they're not drawing 8ths here and 4ths over here. Later they will. Okay, now I have to think about what I'm doing. 2 2/5. I'm going to do my 2. My 2/5 isn't going to be very big, but I'm still going to draw them as 2. Is that okay? Okay, so I need to know that this is 1. I know I'm going to break it up into fifths. This is me. I like to really see where my holes are. It's just for my brain. Except that I just put it in the wrong place. And I've been doing a lot of these. We all make mistakes. That would have been catastrophic if I kept going. But correcting yourself in front of kids and accepting kids correcting themselves and making these little errors often helps one another, because now I can go back and say, oh boy, can't you see the importance of counting this out correctly, where I jumped and did it carelessly. So I'm using my mistake to say, please don't make the same mistake I did, learn from me, instead of having to make it yourself. So I now have my 2 1s. These must be fifths because those are fifths. And I'm going to take away 4 fifths. The first strategy takes it right off the end. I have, now I'm getting scared, I do have 1 3/5 left, correct? The second way, there's my 1, that's 1 2 3 4. I am like determined not to do this correctly. 1 2 3 4 5. 1 2 3 4 5. 1 2. This second strategy just takes it away from 1. I personally would probably take it from this end. I have 1 hole left and these other 3 fifths. You want me to draw that? It doesn't help when I'm making errors.
I'm just curious, if they came up with like 8 fifths, would that be acceptable, or you want them to break that 8 fifths down to 1 3/5?
It would be acceptable. I would ask what else other people got, and we would talk about the difference. So the difference between simplifying and leaving it, they don't even want us to use the word improper fraction, but they haven't given us a new word to say. So I'm going to use improper fraction. We would talk about why those are equivalent, and we would leave it 8 fifths. I really think there's probably a child in every classroom that would do for this 2 2/5. Here's 1, here's my 2 fifths. I need to take away 4. I think there's going to be a child in there that knows they need to only break one of these apart to take 4. And we would have a great discussion. Are those the same thing? They are equivalent. And this person, honestly, is just thinking a little bit ahead of the game. But it makes sense. Because we don't want them breaking eventually. We don't, if it was 13 2/5 minus 4 fifths, we do not want them cutting all 13 holes into fifths. At this stage in 4th grade, we're not there. I would love to have the discussion with them, but as I said, I was in the class today and nobody came up with that. Okay. I am following exactly how the unit does. That was probably a week-long worth of lessons, or 4 or 5 lessons. We are going to jump back to the area model. And we start moving so that they understand what the area model is represented in equations, because we are going to move away from having a model of it. They've built it enough, they've drawn it enough, they can see the equations that equal. So that's where we're heading to next. So we had our 1/2. We wanted fourths, so we drew our other one, and we ended up with 2 fourths. I want to use the term, computationally is what I'm looking at. I want to say mathematically, what did we do? That is a mathematical model, but computationally, what did we do here? We took one piece and multiplied it by 2. We took the whole, which was the halves, and multiplied that by 2. That was not an elegant way to say it, but it is what happened. So I doubled the number of pieces. I doubled the number of the pieces in the 1/2, and I doubled the number of pieces in the entire thing, which is the denominator. And what does that look like mathematically? I multiplied it by 2. Excuse me, I multiplied it by 2 halves. If I multiplied the fraction by 2, that means I'm doubling its size. We are only talking about the numbers. I'm going to pull this out. They get into this especially in 5th grade, the identity property of multiplication. You can multiply anything by 1, and it remains the same value. 5 times 1 is 5. 10 times 1 is 10. Well, 2 over 2, what does that equal? I get a different set of numbers, but the value of the picture hasn't changed. I'm using a new name for it. It's cut into more pieces, but I still have that same area. Does that make sense? Because really, that's exactly what equivalent fractions, that is the arithmetic that proves how the numbers change. Okay, so I have 1/2 here. If I look at my one piece, my shaded piece, how would I represent that as a multiplication problem? I'm going from 1 to 4. So I'm multiplying that by 4. I'm multiplying both areas into 4 greater pieces. There's my 1 again. So my value is staying the same, but its new name is 4/8. Light bulbs going off? Not quite yet. Okay, if I want this as 1/5, I believe, and I want 15ths, what do I have to multiply this by? I'm going to be picky. Am I multiplying it by 3? Do I want it to be 3 times larger? I want to multiply it by 3 over 3, 3/3, because it's still a value of 1. And I get 3/15.
Is this how a problem would be worded for the child? Like using area model multiplication to provide equivalence of 2 fractions? Like, is that what they'd be asked to do?
No, that's more just a title. That's a title of the section of the unit. That's probably for the teacher.
Okay.
I mean, I think that's a mouthful for kids.
Yep. I'm just thinking, but how do you actually how do you actually word that to a child to ask what you're doing? Does that make sense? I don't know.
I mean, I'd probably say we're using the area model today.
Okay.
I want to find the equivalence of 2 fractions. We've been drawing it a long time, a lot. How could we do it with numbers?
Okay. So that's
So
kind of
it's-
how it would be phrased. right?
Yeah.
You do it.
Yeah. And because they're actually doing it along with it, it kind of makes me know. So how could we do this with numbers? I'm trying to think, why does mine look different? Oh, because I just don't start with the first fraction. They did it like that, it's the same difference. Okay. So we've scaffolded it, and then we're kind of expecting them to move on. Draw an area model to represent 3/4 by shading. Decompose the shading fractions into 12ths. Skip this line. So I have 3/4. Keep switching the colors of my pens here. decompose the shaded fraction into twelfths. How am I going to do that? I want it to equal twelfths.
By 3.
I'm going to need thirds here. So I'm going to multiply 3/4 times 3/3, and I get 9/12. So I want to show you what happened. I mean, one, we started them drawing it more. I also wanted to prove to the kids that this doesn't work only for unit fractions. When we give all of our samples with 1 over something, a kid can develop the rule of, oh, it works for 1/2, it works for 1/3, but what in the world do you do with 2/3? So if we start going off into other fractions, it works exactly the same way. I want to be honest, the area model is really big. It works for multiplication, it works for x squared, no, 2 plus x, the quantity 2 plus x times the quantity 3 plus y. This is a generic rectangle area model. It works for all sorts of math, and it works for fractions. We chose, I would say, I think it is common around the world that we draw the first way we did columns and the second way we did rows. It works exactly the same if you drew them horizontally first and then vertically. The reason we set a rule to it is within a classroom and we're discussing it, it's just easy if we've done it the same way. Mathematically, that is not important because you're still just multiplying the two sides times each other. 15 minutes, okay, I'm looking at my timing. I thought we were done because I'm off on my time today. Okay, but number lines work also. We've done a lot with the tape diagrams, we've done a lot with the area model. I don't want to leave out number lines. They've actually become far more important with the fractions. We used to shy away from them and we found out kids really do understand the math with them. So we're going to convert each mixed number to a fraction. Happens to be greater than 1. We'd have to be greater than 1 to do that. Okay, so 3 1/4. How can I get this to be a fraction? I would start with a number line. I do need to label all my parts. Fix my number. I have fourths, so that's why I'm going to choose to break these into fourths. It came because my number gave me that information. So I know that I have 3 holes, and I know I have 1/4 more. Some kids are going to start counting every single tick. By 4th grade, most of them are going to go, well, if I have 4 in the first one, and I have 4 in the second one, and I have 4 in the third one, I have 12. Again, those math facts coming straight to the head, they're not having to stop and think about them, and that's harping on the fluency. So I have 12 plus 1 more. What's its value? I have 13/4. That's how they showed it here in numbers. 4 1/3. What am I going to break? Thirds. Yeah, I mean, we use the math to help us know where to go. We're going to start with thirds. Give me myself enough room. I need all 4, which again is 12. And if a child is not seeing this, all the classrooms have these sorts of things, and I'm going to throw them a whole bunch of thirds. I'm going to ask them to build one out of thirds. I'm going to ask them to build a second one out of thirds. I'm going to ask them to build 4 1/3 out of thirds, and then let them count them. Most kids, this is representational enough that they understand it. There will be a few kids that are going to need to see it built. And when we build it, I'm going to go directly over the top of it and draw that number line directly aligned with the pieces that we built. By 4th grade, this particular skill, most kids won't need that. And I'll be honest, I would probably show it once for everybody, but I wouldn't have everybody build it. They just don't need it. You get it? Do we need to do 2 3/5? You can do it on your own at home. Number bonds and arrowways. Arrowway is not a mathematical term. It's a name that we've given a way to write stuff down. I was here yesterday. I happen to love it. Not everybody does. That's okay. I call it my stream of consciousness math. A lot of kids, I can do it with this one, would say, oh, 5 2/4, I'm going to add 2/4 together, I get 6, then I'm going to add my other 4th together, and I get 6 1/4. Do you have a problem with that? It's categorically wrong, because 5 2/4 plus 2/4 does not equal 6 1/4. But it is the way we think. Arrowway just gives us a way to write it down. So please, I'm going to cross this out because it's wrong. My thinking was, I can decompose 3/4. Let me see. I need 2/4 to get to a whole number. A whole number is friendlier than a fraction. So I'm going to try to get to a whole number. I have 2/4. I have 1/4 more. So I'm thinking, I have 5 2/4. I show you that I'm thinking with my arrow. I'm going to add 2/4. I get 6. But now I need to add my last 1/4, and I get 6 1/4. I'm never claiming that each of these are equal. I'm just showing you what thought process I was going on in my head. Some kids are going to like this, some kids aren't. We show it to all of them so that they have the opportunity to use it, but we don't make them use it. Not that I would expect this necessarily. I could also think of 3/4. I could do 5 2/4 plus 1 whole is 6 2/4. But I added 1/4 too many, so I'm going to take it away, and I get 6 1/4. The reason I'm showing you this is this arrow is just telling you that I'm thinking. It doesn't mean addition, it doesn't mean subtraction, it doesn't mean anything. It just tells you that this is my stop along the way. I think that's pretty cool for a kid to do it that way. I don't think it's likely. In other problems, they might do that though. 19 plus 19, you might do 20 plus 20 equals 40. Now I need to take away 1 because I added 1 and I need to take another 1 away. So this just shows you, this is just a flexible way when a kid said, oh, I did it in my head. And I say, please show me what you did in your head. Because they did not write out a series of equations in their head. So we show this to the kids. They are shown this in 1st grade, 2nd grade, 3rd grade. This is the first time they're using fractions with it. So 7 8/12 plus 11/12. I want to get to a friendly number. So I need 4/12. So I could do, oops, that's 11/12 in a number bond. I know I want 4/12. how much else would I have? 7/12. Does that make sense? All I'm doing is decomposing this 11/12 so I can use a friendly number with that 8/12. So I have 7 and 8/12. I'm going to add 4/12 to it. I get 8. So I've added that part. Oh, I better add that 7/12 that's left. And I get 8 and 7/12. A lot of kids would also do that on a number line. And when we show them that, it's far more intuitive for most kids than adding the 8/12 to the 11/12 and getting 19/12 and taking out 12/12 out of it. This is two different ways of thinking about it than the way I was taught. I was only taught you had to add them. You had to pull the ones out and see what you had to do.
Can
Now-
you do this using the area model?
No, that's about fine. Yes, that's a little different concept. This is adding. You could do this with a number line. You could do it with a tape diagram. The area model really is about multiplying and dividing the denominator. Because you're adding on, you are truly changing the amount that's there. I want you to also think, what if I made the 11/12 the whole number? Well, I could subtract it, or could I just do 7 and 7/12 plus 1? But if I had chosen to change that 11/12, I love it. I had a first grader yesterday. She snatched one. She would snatch 1/12 from here, give it to the 11/12. I now have 1 and 7 and 7/12. This is the flexible thinking that we want from our kids, not just plug and chug. Use decomposition to subtract the fractions, model with a number line or the arrow way. Okay, I'm going to think again, how can we make this easy for ourselves? Can I break 4/5, can I decompose 4/5 into two fractions that would help me with 5 and 3/5? Yeah, I like subtracting 3/5 from 3/5. So if I subtract 5 and 3/5 minus 3/5, I get 5. I still need to subtract that other 5th, and that is something kids are completely, intuitively they get that. I should say most. Compared to taking 1 out of my 5, turning it into 5/5, adding it to the 3/5 to get 8/5, to then subtract 4/5.
So they don't need to show their work in that step. Like, they don't need to show breaking down that 5th into
Yeah.
the last part where you take the 1/5 from the 5 to get 4, and
No,
you're not expecting a step there to show.
not in 4th grade.
Okay.
There is a reality of the classroom. I know she gets it 100% and is doing it totally mentally. I know she can't even add 1 plus 1. If she did that mentally, I may ask her to explain it to me, but that's because we really do know our students that well. But I'm going to ask her to explain because she may have had a tremendous aha moment and it totally makes sense to her. Because that is how our learning doesn't progress in this nice flat line. We go up stair steps and we go back down some steps sometimes before we go up the rest of them. But no, 5 minus 1/5 is completely reasonable. So they also said with a number line, so let me try this. So I'm going to have 2 and 3/8. I should have drawn a better number line, but you're going to accept my faux pas there. I have 2 and 3/8. I need to take away 5/8. Okay, again, I can take away the first 3/8 and I get to 2. So I've broken my 5/8 into 3/8 and 2/8. So I've taken away, and if I need to do a check to keep track of what I'm doing, that's fine. I took away my 3/8. I need to take 2/8 more away. I land right here, and I am at 1 6/8. Does that make sense? I would imagine in the curriculum they're doing the number line. I would probably teach the number line before I do the arrow away, except a lot of kids know the arrow away. We are not teaching the arrow away again. There are kids who absolutely get it and they think that way and they're being welcomed. It's just a notation. It's not anything particularly mathematical. It's just a way to show your thinking.
Does the snatching method works with the subtraction and only the math?
You tell me.
It seems to work great with the math.
With the adding.
Mm-hmm.
Yeah, and I will tell you. So if you think, here's the question I can ask you. Does 5 plus 3 equal the same as 3 plus 5? Okay. Does 5 minus 3 equal the same things as 3 minus 5? No. So no, snatching doesn't. So that means in an addition problem, 5, 6, 7, 8. It really doesn't matter how we group it because we put them together, and that's not true about subtraction. But that snatching, as I said, that word came from a first grader. It works in the numbers they're working in first grade. It works in the numbers in third grade. It works with the fractions in fourth grade. So if you're thinking of a value, I can chunk it into multiple pieces and I still got that same value. That's why I'm allowed to do that.
Speaking about the snatching, you could take from the 2, the 8/8, and make it 1 8/8 and then add it to the 3/8.
Which I'd say, yeah.
You can do it that way.
Yeah, you absolutely could. And you're getting closer to the what I would call the standard way that Americans were taught how to do it. Although it would have been on top of each other. I would argue you're going through a lot more work than this child just did. But if you need to, you do. I think that's a fairly, I think we only did it that way because that's some adult told us to. I don't think it's a natural way of thinking. It's not wrong. In fact, it's very right. It's the way we did it. It worked every single time if we did it correctly. It's just a lot of steps. And you get into bigger numbers. You know, so you end up with 2 and 11/8.
1 and 11/8.
I'm sorry, 1 and 11/8 minus 5/8. And I'm going to let you do that. If that's the way you want to do it, I'm going to let you. I'm not sure I'm going to show the whole class how to do that yet. If it came up, I'd do it, absolutely. And then we talk about what's the difference between there and which one do you find more efficient. And that's what we come back to all the time. I've got 1 more minute. I don't, I'm 4 minutes over. I do want to tell you that when we say we allow the kids to do it the most efficient way, we really don't accept, there are strategies that they should grow out of. You do grow out of using your fingers for all addition. You may use them for a few things, but not all. So we do accept, I mean, we've got kids in 3rd grade when we're multiplying 5 times 6, and they insist that, no, I really want to add 5 plus 5 plus 5 plus 5. So, it's finally, we finally say, but when we've got larger numbers, that's not efficient. So yes, you are going to have to move on. And then there are other ones that are really just how you see it. But if a child can't move on from 5 plus 5 plus 5 plus 5, they are not ready. I can't make that child's brain change to accept it. I'm going to keep showing them, I'm going to keep moving with them, I'm going to move the rest of the people along. But very few strategies are hierarchical, that once you know the next one, you should throw that one away. Most strategies depend on the circumstance. And that's the thinking we want the kids to do.
This problem that we did with the difference of the 2 fractions, and we showed in the 2 baby
Mhm.
So if it's asked, if they ask them to find a way to anyways, do you expect them to use these two tape diagrams?
No.
Or just one tape
I think they're more likely to do one tape diagram and one number line or something like
So
that.
then these two would not be considered as two different ways, or would they?
I would accept them as two different ways because I see it as two different ways to the big game. And I absolutely guarantee, I don't think anybody's really going to fight it. I'll be there if it comes up on the test. I would be there to say that they are thinking about it two different ways. I don't know that we've ever had that as an issue. Yeah, yeah. And the number bonds have gotten tricky because we had an expert here and she said, you really can't use this. I'm going to get myself into trouble here, but we've got to do what's right, and so we're correcting ourselves. I very carefully wrote this over to the side instead of doing this. That mathematically is factoring. It is wrong. Our resource uses it. Most of the world uses it, but we've decided we should be mathematically correct. This is fine. It's over here. It's simply telling me how I got part, whole. This, I should write it as 5 3/5. How do I break apart my 4/5? Oh, into 3/5 plus 1/5. And now I'm not expecting a child to do this, but they could. But that is the mathematically correct way to write it, not that. Most of the kids don't care. We don't get this down. I'm not going to mark a child wrong who uses that, but we as teachers, now that we've learned the correct way, we can't really keep teaching it the wrong way. It was kind of one of those moments for us to go, So we're making changes. We're all still learning. Thank you very much. Schools, you may want out of here in a hurry. The halls are going to get very loud about